Okay, test 4, dissimilar metals. Again, I'm using tap water with potassium hydroxide in the water. And as you can see, the water's a bit cloudy now. I just momentarily turned the power on before I started recording to see what would happen. I'm using now just probably a 3003 series, grade aluminum. It's the type you can probably just buy over the counter at any hardware store. And I'm also using, of course, the same stainless steel plate. Probably 300 some series, I don't know again exactly if it's 302, 304, 6, 9, 316. I'm pretty sure it's 302, maybe 304. But anyway, my last, 3 videos, conducting this test using aluminum chromate. The aluminum was of a higher grade than this, much more resistant to corrosion. It's used in several architectural engineering industries that require a highly anti-corrosive aluminum. The aluminum chromate used before, the aluminum itself was not what I guess some people call a super corrosive resistant, but it is quite more corrosive resistant than what you would probably buy at like a Home Depot or Lowe's. That is of less quality. Yes, it does cost a little more, but compared to stainless right now, it's still cheaper. The chromate process, though, I'm not sure. I have yet to do research on it, exactly how much it would cost to do that to the aluminum. But I will find that information for you. If somebody already has by now, please let me know, give me some numbers. But this test, really, the series of tests is to show, at least in my mind, that you can apply a coating, a corrosive resistant coating to aluminum and still allow the electricity to pass through the aluminum and continue on its electrolysis process. And in doing so, I found some quite interesting things. In the last 3 videos we saw very little oxygen gas being produced, but a fair amount of hydrogen. And of course the question in my mind still is, where is that atom, that oxygen atom, going to? We did see some bubbles forming on the aluminum chromate, but not enough to really release from the plate. As a matter of fact, the previous test, I believe, there was really, maybe, I think I can count on my hand how many bubbles were actually forming off the aluminum chromate plate. And of course, as you saw, there was a tremendous amount of hydrogen production off the stainless steel. Again, if that is what's happening, I really, really would like to know, where is that oxygen atom going? Anyway, test 4 here. Your standard low-grade aluminum, stainless steel, potassium hydroxide solution, and approximately 1 liter of water. There you go. Wow. Turn the power on. Immediately the electrolysis process begins. There's a very large amount of hydrogen gas being produced. And it's kind of hard to see because the water's getting cloudy. And I think that's because of the aluminum. Again, there's no coating on it. But I can see some oxygen bubbles being formed on the aluminum. Let's turn this off for a minute. Now, there's one comment that a couple of people have told me, that if you put raw aluminum in a solution with lye, that it will start producing gas without any electricity or any current being applied. across the plates. I did see some of that. However, it wasn't a tremendous amount. But given time, it would be producing gas when you probably don't want the gas being produced. Even though it may be just oxygen, I don't know. Sort of defeats the whole purpose and the whole point of this hydrogen on demand, if you will, that a lot of us are trying to achieve. The water is kind of yucky now. I do believe that is the oxidation that's going on to the raw aluminum in the solution. You could probably run some sort of filtering system and still use the aluminum. How much the aluminum completely deteriorates is a good question. In my professional, or the field I'm involved in professionally, aluminum's pretty stout. I suppose if you had a very strong solution, you could deteriorate the metal rather quickly. But aluminum itself is quite a unique metal. Other than the fact you will have a dirty solution in a rather short period of time, that solution is just the oxidation. It's a natural process that happens to aluminum when it's exposed directly to the oxygen, of course. Once you coat aluminum, whether you paint it with, a typical paint, use a primer, or use some sort of chemical and you etch the aluminum, you create a protective coating such as the chromate process, that all goes away. I have done other tests where, of course, I've applied a very thin coat of various other coatings to the aluminum, and of course the electricity cannot pass. However, the chromate does. No dirty water, unlike this, and very little oxygen bubbles forming. Now, I'm no expert in this, and I really, really would like to know if, and I've been told this, that most of the hydrogen production will be coming off the negative plates. And of course the oxygen will be coming off the positive plates. If that is true, then what we have all seen in these series of videos asks a lot of questions, or begs for a lot of answers. Anyway, I was going to make this short, but I'm sorry it's long. I just want to share some more information that I found. And this is probably the end of this series. I might start another one, but keep watching.